Preparing for a business intelligence developer interview. You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What are the main responsibilities of a business intelligence developer? A. BI developer turns raw data into trusted business insight. I gather requirements, design warehouse or semantic models, build ETL or ELT workflows, create dashboards, and validate metrics with users. I also optimize SQL, manage refresh schedules, handle access controls, and document KPI logic. The key is not just building attractive reports, but ensuring decision makers can trust the numbers, understand the definitions, and act on insights quickly. While answering, focus on translating business needs into data models, ETL pipelines, reports, dashboards, KPI definitions, data validation, performance tuning, documentation, and collaboration with stakeholders, analysts, and data engineers. Question 2. How do you gather requirements for a new BI dashboard? I start by asking what decision the dashboard must support. Then I identify the audience, KPIs, required dimensions, time periods, filters, and drill-down needs. I confirm metric definitions, data sources, refresh expectations, and security rules. Before building, I usually create a wireframe and review it with stakeholders. That prevents scope creep and ensures we are solving a business problem, not just visualizing every available field. Make sure to cover stakeholder interviews, business goals, target audience, KPI definitions, grain, filters, data sources, refresh frequency, security requirements, acceptance criteria, mock-ups, and validation with real business scenarios. Question 3. What is the difference between OLTP and OLAP systems? OLTP systems support day-to-day transactions like orders, payments, or account updates. They are highly normalized, optimized for fast inserts and updates, and protect data integrity. OLAP systems support analysis across large historical datasets. They are often denormalized, use facts and dimensions, and optimize read-heavy aggregations. BI developers usually avoid reporting directly on OLTP databases because complex analytical queries can slow production systems and produce hard-to-maintain logic. In your answer, talk about transactional versus analytical workloads, normalization, query patterns, performance goals, data volume, concurrency, historical analysis, and why BI typically depends on OLAP-friendly structures. Question 4. Explain star schema and snowflake schema. When would you use each? A star schema has a central fact table connected directly to denormalized dimensions, like customer, product, and date. It is simple, fast for reporting, and easy for business users to understand. A snowflake schema normalizes dimensions into multiple related tables, reducing redundancy but increasing joins. For most BI dashboards, I prefer star schema because usability and query performance matter. I use Snowflake when dimensions are very large, shared, or require strict hierarchy management. Be sure to mention fact tables, dimension tables, denormalization, normalized dimensions, query performance, storage trade-offs, ease of use for business users, and reporting tool compatibility. Question 5. What are fact tables and dimension tables in a data warehouse? Fact tables store measurable business events at a defined grain, such as one row per order line. They contain numeric measures like revenue, quantity, and cost, plus keys to dimensions. Dimension tables describe the context: who bought, what product, where, and when. A good BI model starts by defining the fact grain clearly. If the grain is unclear, measures get double counted, and dashboard numbers quickly become unreliable. While answering, cover measures, foreign keys, descriptive attributes, grain, additive versus non-additive facts, conform dimensions, and examples such as sales facts with customer, product, and date dimensions. Question 6. How do you handle slowly changing dimensions? Slowly changing dimensions handle attribute changes like customer address, region, or account status. Type 1 overwrites history, which is simple but loses past context. Type 2 creates a new dimension row with effective dates and a current flag, preserving history. Type 3 stores limited previous values in extra columns. I choose based on reporting needs. If users need historical accuracy, such as sales by region at transaction time, Type 2 is usually the right pattern. Make sure to explain Type 1, Type 2, and Type 3 approaches, historical tracking, surrogate keys, effective dates, current flags, business requirements, storage impact, and reporting implications. Question 7. What is ETL, and how is it different from ELT? ETL transforms data before loading it into the target warehouse, while ELT loads raw data first and transforms it inside the warehouse. Traditional ETL fits controlled environments with limited warehouse compute. ELT works well with modern cloud platforms like Snowflake, BigQuery, or Redshift because they can process large data efficiently. I often prefer ELT for flexibility. Raw data is preserved, transformations are versioned, and new business logic can be added without re-extracting everything. In your answer, compare extract, transform, load, and extract, load, transform. Mention staging, cloud warehouses, scalability, governance, transformation location, tools, cost, and when each pattern is appropriate. Question 8. How would you design an incremental data load process? For incremental loads, I identify a reliable change column, such as updated date, or use change data capture. I store the last successful watermark in an audit table, extract only changed rows, load them into staging, then merge into the target using business keys or surrogate keys. I design the process to be idempotent so reruns do not duplicate data. I also handle late arriving records and compare source counts, inserted rows, updated rows, and rejected rows. Be sure to cover watermarks, timestamps, change data capture, primary keys, upserts, late arriving data, audit tables, idempotency, failure recovery, and validation against source record counts. Question 9. How do you optimize a slow SQL query used in a BI report? I first check the execution plan to see whether the bottleneck is scanning, joining, sorting, or aggregating. Then I reduce columns, push filters early, verify join keys, add or adjust indexes, and use partitions where appropriate. For repeated expensive calculations, I consider summary tables or materialized views. In BI tools, I also avoid complex row-level calculations when the database can compute them faster. Optimization is about moving less data and doing heavy work in the right layer. While answering, focus on execution plans, indexes, partition pruning, joins, filters, aggregations, avoiding select star, pre-aggregations, materialized views, statistics, query folding, and reducing report-level calculations. Question 10. What is data modeling in Power BI, and what makes a good model? A good Power BI model is a clean semantic layer, not just imported tables. I model data as facts and dimensions, define relationships carefully, use a dedicated date table, and keep filter directions simple. I prefer measures over calculated columns when values depend on filter context. I also hide technical fields, use clear names, and validate totals against source systems. The goal is a model that is fast, accurate, reusable, and easy for report builders to understand. Make sure to mention relationships, star schema, measures versus calculated columns, DAX, filter direction, cardinality, date tables, naming conventions, performance, reusability, and business-friendly semantic layers. Question 11. Explain the difference between calculated columns and measures in Power BI. Calculated columns are computed during data refresh and stored in the model row by row. They are useful for static attributes like customer segment or order age bucket. Measures are calculated at query time based on filter context, so they respond dynamically to slicers, visuals, and aggregations. For example, total sales should be a measure, not a calculated column. I use calculated columns sparingly because they increase model size, while measures usually provide better analytical flexibility. In your answer, talk about row context, filter context, storage impact, refresh time computation, query time computation, DAX behavior, performance considerations, and practical examples for each. Question 12. How do you validate that a BI report is showing accurate numbers? I validate at multiple levels. First, I reconcile row counts and key aggregates between source, staging, warehouse, and report. Then I test filters, date ranges, joins, and edge cases like nulls or duplicate keys. For KPIs, I compare against an approved business definition and get stakeholder sign-off. I also test refresh results over time, not just once. Accuracy is a process. Automated checks catch data issues, and business review catches interpretation issues. Be sure to cover source-to-target reconciliation, row counts, aggregate checks, sampling, KPI definition sign-off, filter testing, edge cases, refresh logs, peer review, and stakeholder validation. Question 13. What are common causes of duplicate numbers in BI reports? Duplicate numbers usually come from a grain mismatch. For example, joining order-level facts to multiple customer records or product categories can multiply revenue. Many-to-many relationships, duplicate dimension keys, and blending data sources without a clear join path are common causes. I diagnose this by checking row counts before and after joins and confirming the fact table grain. The fix might be deduplicating dimensions, aggregating before joining, or using a proper bridge table. While answering, discuss incorrect join cardinality, many-to-many relationships, unclear grain, duplicated source records, bridge tables, missing distinct counts, non-conformed dimensions, and careless blending across tools. Question 14. How do you design KPIs for an executive dashboard? For an executive dashboard, I start with business outcomes, revenue growth, margin, retention, operational efficiency, or risk. Each KPI needs a clear definition, owner, target, time comparison, and drill-down path. I avoid clutter and vanity metrics that look impressive but do not drive decisions. Executives need quick signal: what changed, why it changed, and where to act. I usually include trends, variance to target, and exception highlights, rather than raw tables. Make sure to cover business objectives, concise metric selection, targets, trends, comparisons, definitions, leading versus lagging indicators, drill-down paths, visual clarity, and avoiding vanity metrics. Question 15. What security considerations are important in BI solutions? BI security starts with least privilege. Users should see only the data they are allowed to access, often enforced through row-level security by region, department, or account ownership. Sensitive fields may need masking or column-level restrictions. I also consider workspace permissions, dataset sharing, export controls, and audit logging. Security should be applied as close to the data model as possible, not only through hidden visuals, because hidden report elements are not true access control. In your answer, include row-level security, column-level security, role-based access, sensitive data masking, least privilege, audit logs, data sharing policies, tenant isolation, and compliance requirements. Question 16. How do you improve dashboard performance in tools like Power BI or Tableau? Dashboard performance depends on model, query, and visual design. I reduce unnecessary columns, use star schemas, pre-aggregate large datasets, and avoid high cardinality slicers when possible. In Power BI, I check Performance Analyzer, optimize DAX, enable query folding, and use incremental refresh. In Tableau, I may use extracts, context filters, or aggregated data sources. I also limit visuals per page. A dashboard should answer questions quickly, not force users to wait for every interaction. Be sure to mention data model design, aggregation tables, extract versus live connection, reducing visuals, limiting high cardinality filters, efficient calculations, query folding, caching, incremental refresh, and performance analyzer tools. Question 17. What is a semantic layer, and why is it useful in BI? A semantic layer translates complex data structures into business-friendly terms. Instead of every report author writing their own revenue logic, the semantic layer defines revenue once and reuses it across dashboards. It hides technical table names, joins, and calculations, while exposing trusted dimensions and measures. This improves consistency, governance, and self-service analytics. Without a semantic layer, different teams often produce conflicting numbers, even when they use the same underlying data. While answering, focus on business-friendly definitions, reusable metrics, abstraction from physical tables, consistency across reports, governed calculations, security, self-service analytics, and reduced dependency on technical users. Question 18. How would you handle a situation where business users disagree on a metric definition? I would first clarify the business use cases behind each definition. Often the disagreement is valid. Finance revenue, booked revenue, and recognized revenue may all be different metrics. I document formulas, filters, exclusions, and data sources, then bring the right owners together to approve standard definitions. If multiple versions are needed, I label them clearly. The worst outcome is hiding disagreement in report logic, because that creates mistrust when dashboards do not match. Make sure to cover facilitation, documenting definitions, identifying use cases, data lineage, executive ownership, metric variance, governance process, versioning, and preventing silent inconsistencies across reports. Question 19. What are late arriving facts and dimensions, and how do you handle them? Late arriving data appears after related warehouse records are already processed. A sales fact might arrive before the customer dimension update, or a correction may come days later. I handle this with unknown or inferred dimension members, then update keys when the dimension arrives. For facts, I use reprocessing windows or CDC to restate affected periods. The important part is auditability. Users should understand whether numbers are final, provisional, or subject to change. In your answer, explain delayed source data, unknown dimension members, surrogate keys, inferred dimensions, backfilling, restatements, auditability, reprocessing windows, and the reporting impact of temporary incomplete records. Question 20. How do you manage deployment and version control for BI reports and data models? I treat BI assets like software. Reports, model definitions, SQL scripts, and transformation code should be version controlled where possible. I use separate development, test, and production environments with parameterized connections so deployments do not accidentally point to the wrong database. Changes should be peer-reviewed, tested against known totals, and released with notes. For critical dashboards, I keep a rollback plan. This discipline prevents broken reports and builds confidence in BI delivery. Be sure to mention source control, development test production environments, deployment pipelines, parameterized connections, peer review, release notes, rollback strategy, access control, automated testing, and documentation. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.